he is an accredited energy auditor and a very professionals. He has handled lot of energy audits, lot of energy consulting services. He has published lot of energy engineering, electrical and energy conservation books. He has a website. He is a good blogger. He is continuously feeding all the energy database, all the energy awareness blogs in throughout groups, and he's well respected in IAEMP fraternity, and he was ex-vice president, central council member of IAEMP. He is currently he's a life member of Indian Association of Energy Management Professionals. I hope you will all love to join. And see Ashokji, without any further delay, let us start at 8 o'clock your presentation. Ashok sir, the floor is yours.
Thank you, Vibhuji. Thank you, Vibhuji. Thanks for giving this opportunity to our IAEMP. Basically, I am going to just discuss about the practical steps to be taken by the energy auditors while conducting the energy audits. So, to start with, we see the energy audit program has 4 stages. What all we have seen in our BE books, what all we have been practicing in our manuals, it is preliminary meeting, then during the audit and the post meeting. I just want to add one more thing. It's a follow-up visit, which makes the audit program as a 4 stages, wherein we can have lot of inputs from the industry as well as we can transfer many inputs to the industry. Basically, the preliminary meeting, maybe it can be a virtual or a physical, to start with before the audit, because this is where we don't go to the industry with a point blank mindset, but we go with a calculated and a prepared mindset to the industry to know their operations, to know their energy consumption. And before going to the industry, let us surf through the net to know about the company or the industry segment or what is the energy norms and efficiency. This norms and efficiency varies from industry to industry. It is a small scale or medium scale or large scale. Everything is available through Google and net. We get all the inputs, and based on that, our mind is prepared with all the data about the industry segment and the industry. And when we have the industry, when we enter the industry, we request the industry always to have an opening meeting and a closing meeting. These are all the procedural practices to be employed or to be deployed by the energy auditor when you enter the industry. I am just talking to you about the practical guidelines only. This will come both the technical details as well as the procedural details, how we can achieve the result in the industry, especially in the energy audit. So during the opening meeting and in the closing meeting, we see to it that we tell the management, we want all the people who are concerned with the energy conservation, the energy management and energy efficiency, all the people, the heads of the department to attend to this opening meeting, then we discuss with them. Also, we listen to the management's intention and what is their idea and what the intention of management is carried over to the middle level or the shop floor management. Both the things are checked in with it. So everyone in the plant must be aware of the energy audit, as well as we are able to collect the preliminary audit. Means it is done over mail or through virtual meet, or through, if it is possible, it is local, means it can be done easily also in person. So let us familiarize the energy flow of the given company or the given industry and let us enter the industry. Then this preliminary data collection, see, I am just giving you the procedures. These procedures will have a lot of technical inputs, and I will go into the fundamentals also later in the session. So trailing 1 to 3 years of energy data, both on the electrical and thermal side, then the corresponding figures of SEC, specific energy consumption over the period. Apart from this, when we are there in the industry, the single line diagram of the EB, especially I will start with the electricity and then we'll go to the thermal or boiler and steam side. Not only the electricity input or the energy flow, electricity flow from the main EB incoming to the up to the motors, the capacitors that all been installed at the power house, at the SSB, at the DB and at the motors. What is the level of capacitors that has been put in the industry? This depends upon the linear load or the non-linear load of the industry as well. Let us go into it next as it. Then the most important thing which I find is process and energy monitoring diagram or the sketch. Where all they are monitoring? This is more important. We can make the industry ENMS. Totally we can make the industry energy management and associated monitoring and control can be achieved only if the energy meters are in place, and the in-situ energy meters to be there in each and every machine and motor on the production and utilities. What are the sanctioned demand and what are the recorded variations happening with respect to the sanctioned demand. Also, the energy audit looks into the safety aspects of the industry also, the earth grid details at the powerhouse, what is done in the shop floor and what is done at the transformer end. These are also things to be taken care during the preliminary data collection. After that, when you are entering the industry, let us see whether the loads are electrical or electronic or lighting loads. What are all the types of loads? The single line diagram of power factor, leave alone the capacitors. We take the case of power factor, what is maintained at the machines, what is maintained at the distribution boards, what is maintained at SSB and at the powerhouse. This is an area where the loss of electrical distribution can be seen visibly by you at the first 1 hour or 2 hours of the industry where you are there. See, the random survey of the given industry before audit or during the opening session of the audit or the first day of the audit, these are all the things that is already available to you. Then let us go into the industry safety norms to be maintained in the PF band. Some industries are maintaining around 0.95. Some industries which are having lot of non-yield loads, they will try to maintain around 0.95 to 96 also. If it's a kVH billing, then they go up to 0.99 or 996. But many of the industries, they don't have 3CT based APFC operation, automatic power factor control operation. Automatically they land into the problem of leading kVRH, and ultimately the voltage sagging and the voltage fluctuations and the leading fluctuations also starts. So each and every industry have an optimum or a normal power factor band to be maintained. You look into your industry segment and accordingly you can plan. Is the power quality issues from the EB is coming to your industry? What is the voltage harmonics you are facing in the industry, and what is the current harmonics that is generated from the industry and thrown back to the grid? These are all the areas you see on the power quality side. Voltage fluctuations means your OLTC transformer is functioning well or not, and what is the number of counters it is moving per day or per hour. This is an idea which will know how much of tap changers is happening in your OLTC. That will decide your industry is maintaining the regulated voltage inside the premises. It also takes care of these surges or spikes or cells or the transients. What are all these SPDs, surge protection devices, or the switching surges can be, how this is avoided in the industry. If it is a case of an electronic or a DC drive or a more of a non-linear load industry, how it is taken care. Next comes these are all on the input side. I'm just going gradually I'm just visualizing myself and all the audience of you. You are entering the industry, how you are taking this side, how you are taking the random survey inputs. Having seen the electrical installation and the electrical distribution, now you are coming to the loads. Let us clarify. See, you have the format to be given by the industry. What is a constant torque load and what is a variable torque load? And invariably, most of the production machines are all constant torque loads, where when the speed is increasing, the power automatically increases and the torque is almost fixed. Whereas in the variable torque load, this is an area where appreciable energy savings is possible in the industry. I am going to dwell in depth later. This variable torque loads, especially on the centrifugal fans, blowers, AHUs, air washers, centrifugal pumps, thanks to the limiting the static head and the centrifugal compressors. Screw compressor does not come into this. So BE refresher guide, I will suggest each and every one of us to visit the BE refresher guide. They have given a lot of enormous inputs. What is the updated inputs on this energy conservation and management? It is a good use, it's a good input to us. When you enter the industry, you also see what is the energy gradient that is happening in the industry. The transmission and distribution losses, what we talk in India, it has come from 35% to 20%, whereas throughout the world, they are maintaining around 4 to 6%. That is different. But what is happening in the industry? See, for every 100 units per hour, that is the input that is given on the SCB meter, around 30 units is only delivered to the process auxiliaries or the process utilities or the heat exchangers or any, leave alone the drops that is happening in the transformer, in the motors, in the bearings and couplings, in the pumps and the control valves, in the piping networks. So whatever we see, 1 unit of saving, what you are able to achieve in the tail end, at the load end, it is almost 3 units at the generation. So this is the area you have to look into the industry. See, the idea of the energy auditor visiting the industry, it is not a fault finding exercise to strictly say, but in another way, I can say it is a fault finding exercise only where they are deviating from the practices, where they are deviating from their design, and where they are deviating from their norms. This is what we are going to work upon it. Coming to the next preliminary data, see the data collection is going on one side, and already see this is supposed to be given by the industry before you enter the industry. But if it is not given, most of the industries give it during the time of audit also. When you go in the first hour of audit, they will give all the details. The nameplate details of all the production and utility equipments. This is more important. This will show where is the rated capacity and where the units are or the equipments are running. Bureau of Energy Efficiency always says monitor to target the energy consumption. So the equipments are having with in situ MFT multi-function meters. See, MFT meters, I am trying to say basic level of monitoring, volt and amps. Then comes the energy, kilowatt, kVA and kVR, kVRH, and all the aspects. See, classify the industry whether it is a VFD driven machines or non-VFD driven machines. Then comes the motor. Loading is the first and the foremost priority to decide where is the efficiency loss that is happening in the motor. In the motor loading, if it is below 50%, it is a point to be checked again and again. And it is average loading, means say 50 to say 70% or 80%, it is optimum loading. And above 80 to 90%, because the motor also gets deteriorated over 5 years or every 10 years. So if it is going above 80 to 90%, again, it's a point to note, and you have to take note of it. See, these are all the alert areas, all the visible areas, where focus areas where you have to note down. See, once you enter the industry, you go to the maintenance department also to know the rewinding status, how many types of rewinding, how much of rewinding they are doing in the industry, and why the motors are getting again and again burnt out in the industry. See, an energy auditor is going to the industry to do the root cause analysis. He is not trying to do the suppression of facts, or he is not trying to find the how to find the post-mortem. We are not doing. We are trying to see the root cause analysis. When the motor burnout is happening repeatedly, means why it is happening, how it is happening, how this cannot be happen, it cannot happen, how this cannot be repeated. That is what we have to educate the industry. And having done more than 400 to 500 units energy audits, I come across many, say 7 out of 10 industries, they don't even have the tachometer and a stroboscope to measure the motor RPM or the machine RPM and the monthly recording of the same. It is a matter of few minutes. Say if you take some 1 hour time, say you can even cover some 40 to 50 motors across the industry. You can cover in the premises with a stroboscope. You don't need to switch off the motor also. Bureau of Energy Efficiency in the rewinding practices, they say go with a stroboscope. This is a latest tool we are trying to add in our energy auditing tools and tackles. So the motors in production and utility, the run hours per day, that is also more matter to us. When it is running for 20 hours and above, that motor has to be checked more thoroughly. And wherever the safety fails, this is where you have to educate the industry. Whenever the safety fails, conservation also fails and the breakdown starts. So the instantaneous monitoring by the thermal imager on the safety aspects, that also helps the industry to avoid the failures and not to repeat the failures. All the preliminary data collection is over in the industry, either before or in person or during the first day itself. Then we look for the energy conservation proposals. It is low cost, high cost, but based on the root cause analysis of inefficiency. This is more important. Everyone says the symptoms that has happened, and for that symptom, we are giving some suppression of, we give advice to suppress the symptom. That is not correct. We have to give an advice to the industry in our audit report to avoid spot the root cause and try to root out, nip in the bud of the problem in the industry. That is why the maintenance in the industry is almost, they are having both predictive condition and preventive maintenance. Most of the industries are doing only preventive condition monitoring. Whereas as an energy auditor, you have to educate the industry for predictive monitoring also with the infrared thermal imager. And if you are having for a pump audit, means the ultrasonic flow meter also is required. And look into the subsystems of any of the production machines, auxiliaries, as well as the utilities, how much of automation is done in the industry. I will go in later in the how the subsystem automation is helping the energy efficiency of the given utility. Then this reduction of KVA, whether the PF instruments has been done in stages. Many of the industries, most of the industries, they do only in the power house. They don't come to the, whatever you talk about the load and compensation, it is not done in many of the industries. In fact, recently we did it's a big reputed group, having done that 20% of their 4000 kVA capacity, they started revisiting to their electrical distribution, and they have done that load and compensation, and they're able to almost switch off their active filter, because active harmonic filter, because of this. See, where the harmonics can be arrested at the point of VFD, that is more important. And where the power factor improvement to be done at the load, that is more important, not at the powerhouse. Then comes the motors or pumps or blowers or compressors. What is the sizing and what is the loading? See, these are all the random view you get in the first day. Sizing and loading will decide whether the equipment is operated or the utility machine is operated correctly or wrongly. Compressor bank, you see a battery of compressors, like say 6 or 7 numbers are there, 2 or 3 are there. What is the base load and what is the modulating load and how they are operating? The base load should be almost 2/3 or 3/4, and the modulating load should be 1/3 to 1 quarter. The modulating load has to be fixed with a VFD only to pin down the pressure band. So the compressed air flow balance, what is generated, what is used, and what is leaked, that is also more important. Many industries are giving a more focus on this compressed air leakage now. Coming to the improving the health of the system. See, many of the industries, they think the MOC, what they have decided some 10 or 20 years back, they have gone for MSERW, especially on their water lines or on their compressed air lines. They are now for the compressed air lines, many are going for PPR lines, and now recently many of the industries have started going for aluminum piping also. And some of the sophisticated industries, large volume or the large scale industries, they have gone for SS piping also. Whatever the piping you do, if it is a pump, the eccentric expander at the start of the delivery of the pump, this is more important when you see in the industry. Whatever you see in the industry, you try to visualize what is the internal energy flow. It is a process flow or a media flow or air or water or whatever is the process liquid. You visualize the flow and where the bottlenecks are there. What is the pain point in the industry? The management tells or the middle management tells, or you listen to the shop floor more. If you listen to the shop floor more, you will get more true inputs from the industry. Almost all the industries, they are losing on these belts and pulleys thanks to the V-belts. The V-belts is already started phasing out. It has becoming an obsolete product now. These wedged belts and these cogged belts, that has taken over these V-belts, and it is doing an excellent job now. And on the HVAC segment, what all the air-cooled condensers we have, that is supposed to remove or exhaust the heat enthalpy from the existing premises. So indirect evaporative coolers as a retrofit. See, you also, when you go into the depth of the industry, you also look into the proposals, what can be done. Instead of pointing to the proposal, what is the symptom of inefficiency, you also see what is the solution can be given so that the problems do not repeat and they get an energy saving. Many people think the boiler is doing an excellent job, and in fact, all the package boilers up to 2 ton or 4 ton, we have seen almost 20 to 30% the steam is having so much of wet steam in that. We have suggested to many of the industries, 10,000s of boilers are working in this textile processing region where we are working during the audits. Having fitted the moisture separators at the boiler end and at the heavy equipment end where there is the indirect heating is required, they could achieve their productivity. Thermal productivity went up, their steam consumption also dropped down, their fuel consumption dropped drastically, more than 10%. Actual feed water improvements. See, we all follow the BE thumb rules, but BE thumb rules is just followed not only in the paper, but it is not in the field. That is what we are given to understand. Everyone says feed water temperature of the tank 6 degrees, this one rise I am able to receive. But having done so many audits, we found the tank temperature is almost only at 60 degrees. When you put a trend of taking the RTD reading of the tank temperature, it is only 60 degrees. They can very much rise to 90 degrees thanks to the moisture separator that is going to be fixed near the boiler that can just feed the so much of water steam, that is the high temperature water condensate out, and they can increase the temperature of the boiler input. So the energy audit is basically not to look at the delivery of the utility, but it is we are supposed to look at the suction loss that is happening in the production and the utility machines. This predictive maintenance and preventive maintenance, this predictive monitoring, it has already taken over in many of the industries. Thanks to the infrared thermal imager, you can see the top half is the predictive maintenance and the bottom half is the right side, it is a preventive maintenance. The industries which has been doing this potential for failure, which has been happening in minutes and hours and days, now it started taking in months and years, thanks to the predictive monitoring. And you can see many of the industries still they are seeing the pulse, they are seeing the smell, by visibly they are saying this is the wrong, that is not correct. That is the old school of that. The latest inputs to the predictive monitoring is how we can do the oil analysis on the gearbox or on the any of the system, internal system. See, we have done a TFH audit. We found the carbonization of the oil was so bad, they did not replace for many years. Once they started replacing the oil, they are going to top up the oil, removing the oil, and they started decarbonizing it. The TFH heat transfer efficiency improves by more than 20% as it. That is more important. Then this infrared thermal imager, it has become affordable now. And comes the vibration monitoring, then comes the ultrasonic waves. The sonic imaging and all that is being used in the air, compressed air, that is the latest trend. But basically, you are supposed to have an infrared thermal imager to all your energy audit inputs. See, the infrared thermal imager is one of the tools which can help you to give more of proposals in your energy audit also. Normally, we have been using this thermal imager for more than 10 years now. Throughout the world, the industry is using only for the electrical distribution from the power house, and they come up to the motors only. But we have been using extensively in all the equipments, on the process equipments and the utilities, and we could derive more of energy conservation proposals by the hotspots. In the energy flow, as per the energy conservation law, wherever the hotspot is there, whenever the energy flow is getting stuck for a given utility or given for the production machine, this getting stuck, that is the point of origin of inefficiency. That point, if you are able to tap it, if you are able to focus it, if you are able to pinpoint in your energy audit, this is more important now. So machine condition monitoring as a system, and energy and raw material, the production takes care, the industry production takes care of the energy and the raw material. Basically, the raw material and the output, final product, they are taking care. But the energy, what is inputted to the industry, what is distributed, and what is used and what is wasted, this is where the energy auditor has to lay your hands to give you a lot of inputs. So micro level monitoring of all the process parameters or the energy parameters daily, and macro level analysis. This is what is wanted in the industry now. Just a sample of how we have used the thermal imager, say right from 2012. In the motor power transmission, what we have found is, in many of the motors, our energy team engineer, he will first go with the thermal imager, he will spot what lot of inputs, and he will come back to us and say, this is right or this is wrong. The energy flow or the power flow from the motor to the machine or the power transmission, once it is subtracted and so much of slippage in the belts and pulleys, and you can see almost 80 degrees of temperature in the pulleys, well, the motor itself is only 60 degrees. And when the machine is started, we could find so much of rubber smell was there when the machine was started. See, so much of misalignment, so much of leakage, that is slippage of the belts and pulleys. This needs to be corrected, we have told the industry. Then comes to the electrical, the compressed air side. In the post air cooler of the compressor, within the hood, if it is not working correctly, if it is malfunctioning, or if the suction of the compressor is getting starved, automatically the temperature of the delivery temperature goes up. The compressor OEM always gives a FAD based on the input what is given to the compressor at 20 degrees. Their FAD monitoring is done at 20 degrees, and what is delivered is at 45 degrees and above, means it is a loss to the industry. Leave alone the compressor receiver, you see the refrigerator dryer. Throughout the industry, we have been using it. The input and output temperature will say whether the refrigerator dryer is working healthy. Leave alone the dew point of the, you are monitoring the dew point as well as you monitor the input and output. This will show by cooling the air, you are able to remove the moisture, and the equipments, the pneumatic equipments in your industry is receiving only the cool dry air to their equipments, pneumatic cylinders. This starts, say, it is not a blame game what we are doing as an energy auditor in the industry. We are trying to find the faults practically happening in the industry. The problems identification happens once the origin of inefficiency starts in the utility machines right from the installation. You go to 10 industries, out of 10 industries, 8 industries or 7 industries, they will have their compressor with an open hood at the top. It has to be hooded and it has to be totally taken out. If the compressor air is cool or the compressor house is cool at the ambient temperature, say it's around 40 degrees, means the house also it should be at 40 degrees. If the house is at 45 degrees or 50 degrees, this shows you are losing almost 5 to 10% of compressed air loss within the compressor house itself. Coming to the transformers, the loading and the effects are due to the linear and non-linear loads. What is the load and compensation? What you have given for the on the secondary side of the transformer? What is the no load KVR? What is given for the transformer? That is also a matter to the industry, especially in the COVID times. Many of the industries paid a heavy penalty due to transformer they did not switch off and it went to almost 0.2 or 0.3 power factor and they lost heavily. They were paying 1 lakh as a power bill, they are paying almost 1.5 lakhs towards the power factor penalty bill. Leave alone the power factor, the harmonics reduction also, it has to be in stages. The OEMs or the harmonic vendors, I don't complain about the vendors. When they talk, they want to do all the activities only in the powerhouse. Let them come to the field. You do the stage-wise PF improvement for a linear load distribution, and harmonic reduction has to happen in any of your motors if it is a VFD driven. H5 and H7 are the main critical harmonics, and if the harmonics is arrested at source by the line reactance choke, at least 1/3 is arrested, 1/3 is controlled, and then you take to further to SSB with detuned this one RCC, and then go to the powerhouse. The energy losses in the electricity. What is the voltage drop from point end to end? In some industries, they repeat almost 40 volts because nowhere the capacitor compensation has been done in all their loads, in the tail end loads. Some industries, they say, sir, we almost drop only 5 to 6 volts or 7 volts only. Some industries are also like that. Coming to the production machines, ILC production machines are they restored to the rating. Say, when you go into the industry in the shop floor, you talk to the production person, you talk to the maintenance person, you talk to the maintenance electrician, technician, mechanic. They will give a lot of inputs to you about the health of the equipments. Coming to the air conditioning plant, what is generated, what is distributed, and what is usage? In many of the IoT based, the recent happenings in the IoT, the usage, they have done a lot of automation in the USC to prompt the usage, to optimize the usage. But generation also is important. We are talking about 2 kilowatts per ton. Now it has come to less than 0.5 kilowatt per ton. Thanks to all the magnetic chillers that is coming in the packages and chillers, it is coming with a huge cost. On the existing HVAC plant or the chiller plant, how much you can reduce? This is more important for an energy auditor. The industry wants you as an energy auditor only to address to the first to the low cost, zero and low cost measures. Then you talk about the high cost measures. You go to the industry, you say you replace the transformer or you replace the chiller. They themselves know it. They don't want you to tell that. They want you to study the existing inefficiency in the existing chiller and then suggest the ways to remove or avoid that. Compressors, generation, distribution, usage, and leakage. Leakage is taking more. Leakage is taking more in the compressors. In fact, many of the up to 50 HP compressors we have seen, 50 HP compressor almost gives around 250 to 300 CFM, but the leakage is happening more than, it is abnormally happening. A quarter-inch leak, almost it goes to 100 CFM, whereas a quarter-inch piped hose, it takes only 30 to 40 CFM. You cannot allow the leakage to happen more in the industry, but leakage is bound to happen. What is your industry norms? Each and every industry has the norms. My industry norms is less than 5%. It is fine. You go by the industry norms. Also, the fans and blowers, thanks to the Bureau of Energy Efficiency refresher course material, I should say, the static pressure monitoring, Pascal monitoring, this helped us in a big way to analyze the blower efficiency, and we can come out in a big way in the industry. Each and every industry talks about replacement of total blower to EC fans. Electronically commutated fans, it's a system change. But Indians are all used to the heavy inertia. We have inertia inbuilt in the system. We have bought a equipment or a utility for 10 years back. We don't immediately replace it. We try to see what is maximum possible that is possible in the existing utility or in the production machine. Then only we talk of replacing this. So commissioning of all the above utilities, the AMC reports. If you say about a compressor or if you say about the transformer, what is the no load loss at the factory during the pre-visit, or what is measured in the factory during the loading conditions. And you see in the compressor means what is the FID done in the compressor during the commissioning report. The commissioning report is to be the reference for the any energy auditor to go in depth of the compressor distribution also. Coming to the compressor distribution, you also see to the logbooks. See, reading the logbooks and having an analysis of random survey of logbooks will say what is the nature of breakdowns that is happening in the compressors. Also, you are supposed to have a broad eye view or a broad aerial view of the compressor layout diagram end to end. What is the header pressure maintained? Some of the industries, same segment you go, some industries will maintain at 7 bar, some maintenance will maintain at 5.8 bar, some industries maintain at 7.5 bar. The more and more the bar they are maintaining increase their header pressure, it means they are not able to arrest their leaks. That's why they are raising their header pressure. What is the filter drops that is happening in the compressor house? That is more important. What is the delta P across the filter? What is minimum? What is maximum? And what is the allowable? The filter OEM is supposed to educate the industry or educate the auditor also. What is the normal pressure drop across the filters? Then comes the flow meter. In fact, we have seen many of the 160 kilowatt compressors giving a delivery of 1000 CFM, but none of the compressors, they have a flow meter. The flow meter was provided before, it was costing more than 2 lakhs, 3 lakhs, but it has come to an affordable 1 lakh now. And it can give you a reading of shift-wise reading, what is the flow, or hour-wise, or totally, they can take it for a month and they can analyze it. Ultimately, the rated watt per CFM for a given compressor and what is the running watt per CFM, that will decide whether you have to change, you have to give a proposal to change the compressor or to do any modifications within the compressor. This is an example where we have done an energy audit, and this is based on the inputs flow metering trends by the Synthetech Coimbatore. Basically, it is a 110 kilowatt compressor, but they are using a wrong sized dryer, 600 CFM. Automatically, the pressure drop was more than 0.8 bar at the compressor house. So, the suggestions were given, and it is well taken by the industry to increase the dryer size or to improve the air intake filtration. This is where many of the industries are turning a blind eye. In fact, the IoT people can come in and have a air intake delta P monitoring and control also. Swapping, that is a regular monitoring. See, the air intake paper type filters, they can have almost 3000 pascals every 3 months. You don't allow the filter to choke to 3000 pascals. Wherever the filter is crossing 500 pascals or 1000 pascals, you start cleaning the filters or pre-filters. Automatically, the compressor will be in a healthy mode to deliver the output. And the pressure control sensor at the compressor, the OEMs are doing it. See, company from Sweden or company from Germany or company from Switzerland, they can deliver their equipment because they are giving to thousands or millions of consumers. So they give their pressure sensor within their board, but it is to the user or the energy auditor to educate the user, relocate the pressure control sensor to the immediate air receiver. Automatically, you can see these pulsations can be very much avoided if this pressure control sensor has been relocated to the air receiver. And the cleaning receiver, it has to supposed to have a buffer type air receiver to schedule the cleaning as well as the cleaning type receiver also to be maintained in the compressor. See, many of the industries, they are losing more in the cleaning and they are acceleratedly aging their compressors because of their fluctuating cleaning schedules. Coming to the pumps, I'm just I am visualizing you all as a part of my energy audit team. We are going inside, we are seeing what is there in the industry, preliminary data collected on the electrical side, distribution side, motor side, then compressor side, then pumps. The pumps, which is used for heat transfer applications, the in-situ monitors or the in-situ pressure gauges, the pressure and temperature gauges across the pumps at the suction and delivery, across the cooling towers, across the heat exchangers. All these inputs, see, many of the industries, wherever you go, almost 7 out of 10 industries, their pressure gauges are totally out of order because they are fixed on the line. Due to line vibration, within a week or within a month, the pressure gauge goes out of order. They can as well put an impulse piping from the pressure gauge from the main line and fix the pressure gauge on a wall and then give you a comfortable mounting for the pressure or temperature gauges so that will also indicate all the span of 10 years or 20 years. The pressure gauges on the pipelines, on the compressor or on the water circulation lines, end to end will show the pressure drops. The pressure drops, see, the BE norms always says that it's around 0.3 kg on a 7 bar line to be maintained. If it is less than 0.3, it is excellent. The MOC, the material of construction, I have already said about that. The water cooling or the circulation rates, I will just take a leaf from the thermal stations. Still, many of the thermal stations which has been using 6 liters to 7 liters of water to produce 1 unit, the norms have been laid to the thermal stations. Now they have brought to 2.5 to 3 liters. This is what is happening in the industries. The industry is circulating the water in a double the time. It is not required. You try to circulate the water, optimum circulation to achieve the heat transfer, to achieve the heat exchanger, and definitely water circulation also the energy savings is possible in this. Excess watering also leads to excess of energy consumption. The water parameters, what is supplied, inputted to the industry, what is delivered out or what is exhausted out, what is in the ETP, everything is to be monitored. And are we within the norms? That is more important. The energy auditing on the pump without monitoring the suction and delivery pressures at the field, it is totally not at all worth doing the audit, because it will be only a power audit. Unless you monitor the suction pressure and the discharge pressure, the suction pressure also it should be after the suction strainer before the pump flange. And this gives an input whether the pump is, in fact, last week our Dattar was giving a lot of inputs on the pump monitoring side. This is more important. The hidden agenda in the pumps, I am just telling you, the blue lines, if you read, the NPSH for a given pump, or the free air delivery, net positive suction head for the given pump, this goes unnoticed in many of the industries. If this is noticed, definitely we can have a lot of energy savings in the pump. We have done a replacement of decade-old monoblock pump with a open well sub pump. Many people rejected it, but we said we will do it, and we would find a 7.5 kilowatt pump, monoblock pump was replaced with a 5.5 kilowatt submersible pump. It is doing an excellent job, 20% the energy savings, and the NPSH was excellent there. So the energy auditor is supposed to look into the root cause analysis. Means you don't see the delivery of the pump or the delivery of the compressor. What is the FAD? Free, the air should be delivered freely at the suction of the compressor, or the net positive suction head for the given pump should be maintained perfectly. If this is not there, if the pump is allowed to start or if the compressor is allowed to starve, automatically the power kilowatt also goes up and the delivery also comes down. The low-hanging proposals are very much there in each and every utility. It is a site visit and with a keenness on the studying the system. Study this as a system, not as a pump or not as a component. Study the cause and not the effect in case of monitoring the energy flow. Coming to the blowers, it is a eye-opening for us. Every industry or every retrofit to OEMs, they do a lot of changes in the impellers, and they say we have measured the flow before, measured the flow after, they have achieved savings, the kilowatt has come down by 20%. But where all we found the static pressure dropped so heavily. The blower's efficiency is monitored or measured not only by the flow, it has to be measured by the static pressure in pascals and the input kilowatt. In fact, many of the industries, they don't have the blower performance curve or the fan performance curve you are supposed to have in the industry. If you don't have it, you try to retrieve the industry. When the energy auditor, when you go into the industry, you see what is the band. What is the best efficiency point for the given blower or the given pump from their logbooks, from their technical specs? That is an eye-opening point for many of the energy auditors. If you are able to retrofit a VFD retrofit, this will try to facilitate the pump or the blower to operate at the best efficiency point or a best efficiency band. So make provision in all your blowers. You tell the clients or the industry to make a provision with a drilling machine. They can make all the ducts and especially in the blowers to make the pressures monitor static pressure at the blower end and at the delivery end. Both are end-to-end monitoring is also important. If the filters are there, means across the blowers, especially on the HVAC segment, that filters or the delta P across the filters has to definitely be monitored. Then only we can give the proposal on all the AHUs that is possible. Also plan to discuss with the OEMs or with the industry to retrofit VFD and pulleys and belts, resized pulleys and belts with a cogged belts instead of a V belts. This gives an enormous savings. In fact, having done this energy audit, this is a paint industry. They have tried almost 50 sets of blowers for the past 2 years. They achieved 18% savings. What they have done is they already had a VFD. Only thing they resized the belts and pulleys, and they have, instead of 35 hertz, they are, so you can see the fourth line from the bottom. Instead of operating the blower at 35 hertz, they are able to operate at 30 hertz and they achieved 3 kilowatt, straight away 20% savings, and the payback was in 3 months. Having invested 6 lakh rupees on these 50 blower sets, they achieved 1.2 lakhs per month as a return on investment. Try to find the variable torque loads on the blowers, pumps, and compressors, especially centrifugal compressors. Enormous potential is there for energy savings. I'm just covering all the parts of utility as a aerial view only. Boilers and steams. The boiler nameplate and where they are operating. The boiler is rated for 10 bar and you will be operating the iron machines, or many of the process machines are 2 bar. So what is the highest operation at the boiler house and lowest operation at the premises process house? This is important for the boiler. This is unlike the compressor. But follow the BE thumb rules are strictly followed in this industry. The flue gas oxygen trimming can be done not only for 10 ton and above boilers, it can be done for a 4 ton boiler also. The energy savings is enormous if the flue gas automation is done and all the hot or the heat value is totally lost in the flue gas, means it is lost to the industry. So flue gas trimming is automatic oxygen control of flue gas is important. Subsystems like feed water and fuel quality, combustion and flue, all the aspects subsystems can be automatically controlled. This automation of subsystems is more important. Normally, it is we always start as look above, look below, and look around. What is the color of the chimney? What is the how much of drains is going in the how much of steam is going in the drains, and how much of steam leaks is happening around? These are all the boiler inefficiencies visibly seen. But we can see more of invisible losses. Go do the direct efficiency calculations and then is the indirect efficiency calculations. You will see a lot of more. Calculation is easy, but you have to take a lot of data in the boilers. The moisture separators at the installation, at the delivery of the boiler, and at the main branch headers, and at intermediate points, and at the tail ends, heavy tail ends. This gives instantaneous increase in their the thermal productivity. PRD's installation, they have now the cluster management programs by the BEA that we have come across. Instead of PRDS, they are going for this nano turbines, micro turbines. They are able to generate the kilowatt in that PRDS installations. But PRDS installation or the flow metering installation, as an energy auditor, you see whether the installations are done correctly. And most of the industries, they have done with the available piping they have. They are supposed to have a upstream or downstream piping minimum 20 dia, if not 10 dia. This diameter, the upstream and downstream, I am talking about the streamlining of the process flow inside the piping. This is more important. Once the process flow is turbulent, definitely it is an energy loss to the industry. A simple thumb rule, a stream operated at 30 meter per second, it is a normal, it is a streamlined stream flow. Whereas a compressor is operating, or a compressor operating at 10 meter per second, around 6 to 10 meters. It is a streamlined or a laminar flow. This is more important for that industry. See, velocity monitoring is important for a boiler, for the steam line, for the compressor line, or for the blower line also. Blower, it is around 3 to 5 meters per second. This is also seen whether it is correctly or not. And the insulation is the area where industry had started some 20 years back. They will keep the same insulation for 20 years. Many of the moist insulation, it is conducting excellently now in the industry. It is a point of loss, or the exact pinpoint, you can pinpoint the losses. They are supposed to replace their insulation, material once in 10 years, subject to the industry environment and the ambient conditions. Automation of boiler subsystems on the flue gas and on the feed water, even the feed water tank control also, it can be automated, and you see that at the boiler input point where you are delivering 90 or 95 degrees temperature, that is more important. You monitor with your thermal imager, that is enough for us. As I said, it is not only used in the boiler. If the boiler is supposed to have a moisture separator, it is supposed to have an air vent, so that the air vent also can dramatically, if the air is not vented out in the steam distribution, dramatically it will reduce the boiler or the steam performance. Once the air venting is done, it will straight away within few seconds or few minutes, the thermal productivity increases in a given process. So the moisture separator at both the ends, it has to be taken care, not only for the boilers, it has to be sized even for the compressors, where the moisture separator from the compressor to the first receiver, air receiver, that moisture separator has to function fully and sized moisture separator has to function fully as it. So the energy auditor, I am just covering, it's all the technical details. I'm just coming to you when you are in the industry, what you are supposed to see. You always trust the industry. Whatever the management says, whatever the middle management says, you trust them, but you always verify with your monitoring readings. The readings are more important now. The industry is always vendor centric because the vendor is always visiting. See, the energy saving vendor also, he wants to canvass his energy saving product and he is visiting the industry. But you are an energy auditor, you are not canvassing your energy auditing. The industry has to call you to visit to do the energy audit. And see, they think you as an expert. Your expertise has to be fully utilized by the industry. So their mindset from vendor centric to the common mindset, the basic mindset of the logical thinking, technical or techno-commercial thinking has to come, and common sense has to prevail in between. The objective of the energy auditor is to bridge the gap between the design and operation of any equipment, especially in the utilities. In the process, they know very well, they know how to overload the process equipment to get the best out of the process and get the more production also. Every production man knows, but on the utility man, you have to take care of your utility machines also. The OEMs always suggest about the safety of the utility machine, but as an energy auditor, you have to suggest how to run the machine efficiently. That is more important. We differ from a OEM, energy saving OEM, only in this aspect. Whenever you enter the industry, you see to it that the machines are operated safely, but over amount of safety also, over touch of safety is also not good for the industry. This industry can run with a under shadow of safety, but with the energy efficient operation loading, that is excellent. The energy auditor is not a vendor to the industry, but is the best as a partner to the industry to the energy savings. Your energy audit report, once you are done with the energy audit, your report should convey to the industry in their language. You don't give what all that is put in the BE books and this one, don't give that. You have to give your own template. You have to arrive at your own template. The energy audit report needs to have the BE guidelines full and full, but it need not be a copy-paste data. It has to be, the data or the template has to be arrived at for your own asset. And the first few pages, it is meant for the management. The middle pages, it is meant for the middle management. And the readings, it is meant for the shop floor people. And you have all the bar charts and all the pie charts to highlight what all the deviations you have seen in the industry. The industry wants you to only to highlight their deviations. They don't want you to say just like that namesake, don't do the audit. You do the audit for the sake of doing audit and do it plainly, sincerely. The middle management is very much to be informed of the ENCON measures, but proactively discuss with the industry how to achieve the energy savings and motivate the industry. The inertia is there in the industry. They always think, I have run the industry for 20 years, nothing is happening, my industry is sound. But the industry can be sound, but if the utilities can be improved, utility is like a medicine, it's a cough syrup to the body. If the utility also has to be shaked well, and the industry, the premises or the equipments also has to be shaked well, so that the utility is well in sync with the production industries, production equipments as such. Your audit report is a confidential document. The first, if you see, our audit proposals will not be in hundreds or 200 pages. It may be some 50 pages only, but it will definitely contain what is to be done by the industry. This is more important. Your audit report has to be precise to the point. Need not copy the volumes of pages and copy paste formats from BE. These are all not required. The industry doesn't want this. And you have your own template, and it also has to contain the production process and all the parameters, and it has to be strictly confidential. You deliver your audit report only in the hard copy. You don't give the industry to the soft copy to the industry. Once it is given as a soft copy to the industry, it will go for circulation and it will boomerang you and the industry. The collection of true and plain plant inputs from the industry, that is more important to achieve value addition in your energy audit. So the plant management initiates the energy audit. The technical team is aware of the energy auditing and conservation procedures. The culture is there. All the three inputs. You have to, as an energy auditor, you have to talk to all the three people to know the energy education from the top to bottom has happened. This I am telling you because you have seen many of the industry, the management or the MD will talk. he will be talking in flying air, but what is happening in the field, it will be in the rock bottom position. So you have to bridge the gap, and you have to bring the management to the allow the management to ground on the plane has to ground on the land. So know what is the condition, existing condition, and then improve upon it. So energy conservation, it is not only limited to the electrical department or the maintenance department, it is open to all the departments. The responsibility is lying with all the departments. Management, you have to listen to the management, but observe and interact with the shop floor more. Then only you will get more of technical inputs in the field. The maintenance, electrical, mechanical, production and quality, everyone try to interact and try to maximum utilize your time. That is more important. The industry management is always with you for the energy savings, but you have to they are in the first gear or second gear. You have to take them to fourth gear, means the energy auditor only can do this as it. So the result of the energy audit is more, the last stage, which I just told in the first slide, the follow-up visit for any industry, you mandatorily make it. This is where, as an energy auditor, you will learn more about your proposals, how it is implemented in the industry. This is a reverse learning for you. What all the proposals you tell in the industry, whether it is accepted in the industry, whether it is deployed in the industry. And the ENCON measures, when we went for accreditation, Bureau of Energy wanted us to give what is the industry feedback, what is the industry's feedback. That is far more important for the BE or for an energy auditor. You need that. The industry's feedback after your energy audit, that is more important. That is the goodwill you are generating in the industry. Either you can increase their productivity or you can reduce their energy consumption. The baseline efficiency can increase, or the energy consumption can come down, productivity can increase. All the aspects you have to study in the follow-up visit. Follow-up visit will be an eye-opener for you about your energy audit. So make the industry understand your energy audit is a tool to recover what is the energy losses happened for more than 10 years or 20 years. What is the mismatch between the design and process you are trying to address to that. So the energy auditor only can work with the industry if the management is interested. You can canvas for energy audit, but that will not work out. If the management feels there is a loss in their energy loss is happening in their industry, then only you will get a call from the industry and you can do the audit. So either the energy audit can happen in the industry, the prevailing condition is only when the industry volunteers or when the government mandates today to all the ST consumers throughout the India, once in 3 years, this energy audit will happen. Otherwise, the energy audit will not happen. Nothing can be done to us as a voluntary measure. It can be only mandated. This will come as a positive thing as such. This is our IAEMP's vision and objective, creating true wealth from energy conservation. What is talked about the national laws is applied to the industry. The visible laws, the production knows very well. But the invisible laws, you work with the utility or the maintenance on the electrical and maintenance and the mechanical maintenance. And this is where a team of energy auditor and the maintenance can bring the total productive management for the given equipments for the given company and for the given process. Thanks to the IAEMP's, it's a energy part where what all inputs given from the different sources, but so much of leakages is happening. Visible is at least it can be attended. Invisible leakages. This is where the energy auditor goes in and gets the job done, and he gets a win-win situation in the industry. Thanks for giving this opportunity. I have taken much of your time, as I have taken to 9 o'clock. And all these inputs I have detailed in all my 4 books. And thanks to all the IAEMPians who have purchased it. And it will be you can give me your valuable feedback so that we know how to improve upon it further. Thank you. Thank you all.